In today's video, we are going to be discussing aromatic hydrocarbons. And here we have the outline of what we'll be discussing. So, what are aromatic hydrocarbons and the benzene ring? Now, in the very first video of this series, we discussed the classification of organic compounds. And in that video, we saw that organic compounds can be classified into acyclic and cyclic. Okay, and so far in this series we have discussed the acyclic organic compounds or the acyclic hydrocarbons. Now moving on to the cyclic organic compounds, we further divided this into the homocyclic and the heterocyclic. Now, homocyclic organic compounds are organic compounds that contain only carbon atom. So they contain only carbon atoms in the ring. Of course, we know that cyclic organic compounds have a ring structure. So they have a ring structure, while the acyclic organic compounds have an open chain. Now, for homocyclic organic compounds, the ring is made up of only carbon atoms. So we don't have nitrogen, no other atom is present in the ring apart from carbon atoms. Now, under the homocyclic classification, we have the alicyclic as well as the aromatic. Now this is what we'll be discussing today, the aromatic hydrocarbons. Now the simplest member of this group is the benzene, and it has the formula C6H6. Also, something to take note of from this is that from their name they have the name aromatic. Now aromatic hydrocarbons usually have an aroma, they have a scent. Okay, so this is where the name originates from. So let's take a look at the benzene ring. Now, I earlier stated that the simplest member of the aromatic hydrocarbon is the benzene, and benzene has the formula C6H6. It also exhibits the sp2 hybridization. Now, from our videos on alkenes, we know by now that alkenes also exhibit the sp2 hybridized orbitals, and so we might make the assumption that benzene behaves like alkenes. However, this assumption would be wrong. Benzene actually does not behave like an alkene, and we'll see this as we move on in this video. Now the benzene has a structure that looks like this. So it's a hexagonal ring with all six carbon atoms arranged in the ring like this. So 6 sides with 6 carbon atoms. Now all of the 6 carbon atoms and the 6 single bond that exist between them are equivalent, and benzene has a conjugated double bond. Okay, so a conjugated double bond. This simply means that the double bonds are alternated between sides. So if we take a double bond here, the opposite side, which is this, would not have a double bond. And if we take a double bond here, the opposite side would not have a double bond. And if we take a double bond here, the opposite side will not have a double bond. And of course, we have carbon atoms attached, rather hydrogen atoms attached to give each carbon atom 4 bonds. Now this is how the benzene ring looks like. Now, although the benzene ring has the sp2 hybridized orbital, the pi bond that leads to the double bond that we have here, okay, so we know that this double bond is made of one sigma bond and one pi bond. However, the electrons that lead to the formation of the pi bond are delocalized. Okay, delocalization. They are delocalized. This means that they have the ability to move. So this these electrons have the ability to move away from this region. They are not restricted only to that region. And so it has been discovered that the benzene ring doesn't actually have this structure. The structure is not restricted to this form. So this is the form we had earlier with 6 carbon atoms. Now, something like this. Now, the kekule structure is a structure of the resonance of the benzene ring. So it has been discovered that the benzene ring, this is not the actual structure of the benzene ring. The benzene ring actually alternates between this structure and, okay, let me clear, and a structure that looks something like this. Let me clear up the space so we can. Now, the kekule structure. The kekule structure of the benzene ring is its resonance structure. Okay, now resonance actually arises from delocalized electrons. So when the electrons that form a double bond happen to be delocalized, the structure, the particular compound would have its resonance form or hybrid form. Now for the benzene ring, which looks something like this, okay, 6 carbon atoms and the double bonds that are conjugated in this way. This structure actually resonates between this form and this form. Okay, so something that looks like this, 6 carbon atoms, and then instead of having it here, would have it here, and instead of having it here, would have it here, and so on. So it actually resonates between these two structures. This is the hybrid structure of the benzene ring, and to represent this with a single diagram would have something like this. So would have a hexagonal structure that looks like this, okay, and would have a circle in the middle just to show that the electrons forming the double bond are delocalized. And now, I earlier stated that the benzene ring, although it has the same hybridization with the alkenes, they do not behave like alkenes. Now, alkenes generally undergo addition reaction. So they undergo addition reaction and they form alkenes. Now, unlike alkenes, benzene actually tends to undergo substitution reaction. And substitution reaction is a characteristic reaction of alkenes. Okay, of alkenes. Alkenes are the hydrocarbons that generally undergo substitution reaction, and the benzene tends to undergo substitution reaction to form various derivatives of benzene. So this is just a general overview and a very basic introduction into aromatic hydrocarbons. If you liked this video, please give it a thumbs up and kindly subscribe. Thank you for watching. Bye.